The final protocol that we are going to deal in the second unit are the last topic of the second unit, point-to-point protocol. This is another protocol used by the data link layer for sending out the frames between sender and receiver. Okay, so HDLC is one type of protocol, point-to-point is other protocol, Ethernet 802.3 is one more protocol, standard Ethernet, IEEE Ethernet, likewise. Depending on our requirement, we can go for any of the protocols. Probably Ethernet protocol format will be discussed later. So along with other topics like media access control sublayer, during that it is being discussed. Okay, so in this particular point-to-point protocol, the topics that we are going to have are framing transition phase. So if communication is to be taking place between sender and receiver, what are the different phases it is happening? So those phases will be shown with a flow diagram that is in the transition phase. Then using the multiplexing and multi-link, okay, multiplexing. So same link can be shared by multiple stations, multiple protocols. Then multi-link, point-to-point. So the name itself is saying point-to-point protocol, one-to-one communication. So not only one-to-one communication, even one-to-many communication is still possible. So that is by using the multi-link point-to-point. Okay, multi-link point-to-point, right? So that is the second one. So these are the topics that we are going to discuss in this. Okay, so what are the features? There are three features are being provided in this. Okay, three features are being provided in this. So here also the meaning is beginning and ending of the frame indication is there, like flag byte. The way we have used in the HDLC frame format, the flag byte, here also it is being used to detect the proper boundaries of every frame to avoid the errors. Okay, for reducing the errors, to avoid the errors, problems. So proper detection of the boundaries of the frame, that is one thing. Link control protocol for bringing lines up. So establishing the connection. Protocol will support for establishing the connection for proper communication, testing of those connection, whether it is okay or not. Then negotiations between the sender and receiver, certain parameters, like suppose I want to send so many frames per unit time. Is it okay for you? Then receiver will say whether it is okay or not. If okay, fine. If not okay, then I can accept only this. Suppose I say that I want to send 10 frames per second. But if the receiver is capable of only 6 frames per second receivable, no, I cannot receive 10 frames per second. I can receive only 6. Likewise, the agreement between. Okay, that is negotiations. Certain parameters. So like let us allocate so many buffers at minimum during our communication. Let us stick to use minimum so many buffers to avoid any ambiguity. Likewise, the negotiations. Okay, and this point-to-point protocol supports both asynchronous way of communication and synchronous way of communication, bit-oriented or byte-oriented encodings. Both will be supported by this. So this is another advantage, another feature of this. Okay, so even negotiations with the network layers. Okay, all those things, right? So communication, interfacing with the network layer, supporting is being given in this. So these are the different features of this. When it comes to the transition phase, so every link between a sender and receiver could be any sender or any receiver. Okay, so initially what will happen is in the ideal state. Here we are calling this is a dead state, but we can take it as ideal state. No activity is happening in this. Okay, suppose now my mobile in ideal state, the dead state. The moment I want to communicate with somebody, I'll open. Okay, I'll dial. Then carrier detect. Then it goes into the established state. Okay, if the signal is available, it goes into established state. If signal is not available, again it goes into idle state. So when you are trying to dial your friend, when signal is not there, so you are unable to dial, immediately you are going to get call ended, and your mobile will be in the idle state. Okay, if the signal is okay, then you are contacting the other for some communication. So there are either using the login credentials, okay, using the login credentials. So whatever login credentials are being given, if login credentials are okay, then authentication successful. So connection is established. If login credentials are wrong, connection failed. So connection will be terminated. Go back to the idle state. Right? So generally this is being happening with outsiders. So if I am using my own network, my own connectivity, then once login is sufficient, every time simply I can directly start communication. No authentication is needed. If I am the only person using this system and no one else is using this system, then I need not include the login credentials every time. Once I logged in, I'll keep logged in. The moment I select the option, directly I can start communication. So that is why the authentication is not needed. Okay. So if the user is using that system forever, no one else is using, so every time login credentials are not needed, then direct connectivity. Okay. If it's outsider, the login credentials, if login credentials okay, successful, network is established. If login credential failed, terminated, connection is terminated, then go back to the ideal state. Once the network connectivity is accepted, then they can start communication. Okay, they can start communication. Right? For that communication, they can start open. They can start sending the frame, receiving the frame. As long as they want, they can do it. In the open state, as long as receiver and sender want, they can continue their communication. Maybe 1 second, 1 minute, 1 hour, 1 day, 1 week, 1 year, depending on the requirement. Depending on the requirement, they can communicate as long as they want. Once the communication is over, then connection release, terminate. Once connection is released, both sides goes into the ideal state. Okay, goes into the ideal state. Then again, anyone start, again this phase starts. Okay, so that is how the transition phase is being used in the point-to-point protocol for establishing the connection and to make the communication possible between a sender and a receiver. So these are the different phases. So every time if two systems want to communicate, they have to undergo these are the phases. Okay, so same thing is being mentioned in this dead idle, establishing, authenticate. So once login credentials are successful, authenticate, then a network, so they can start, they are authorized to send or receive, then open, and during open they can send this information or receive the information. Once complete, terminate. So these are the different phases what we have already seen. Now this is the frame format of point-to-point protocol. This is frame format of point-to-point protocol. Here also we are using the flag byte. Indicate the beginning of the frame, ending of the frame. So 7E is the flag byte. So generally in the communication computer networks, data link layer is using the 7E as the flag byte almost universally. Almost all the protocols are preferring the same. Okay, so that is flag byte. Next, again the address of the receiver. Okay, sender will, so single address, address of the receiver, to whom this belongs to. If it is a broadcast, the address is all ones. So all ones indicates broadcast address. So this information should go to all. All the users has to take it. Like a circular coming into the classroom, which belongs to all, like all the students are required to pay the exam fees on or before so and so date. So that circular belongs to everyone. So it's a broadcast. Okay, it is a broadcast. So likewise, so that broadcast address is all ones. Then control field. So here the control field is a unique address. C0 is the value used in the control field, because there is no separate control information like what we have used type of frames in case of HDLC. Here not any type of frames. Okay, here no such type of frames. So that is why the control field is being not used. A particular value is being used. Then protocol. The protocol indicates what type of data it is. Here the protocol indicates what type of data is there in the payload field. Okay, whether it is text based or audio based or video based or any control information or any parameters the sender and receiver are exchanging. Okay, so negotiations, right? So indicates that. So what information is moving in this area, based on that the protocol. This information can be negotiations. So I want to use so many buffers. How many you want to use? I want to use so much speed. What is your speed? Likewise, any negotiations and the type of the data, whether it is text based or combination of text and other things are depending on that. Okay, all those things comes under this protocol type and data. So the maximum data that is being used in this area is 1500 bytes. More or less almost all the data link layers will be supporting the data size or payload size is 1500 bytes approximately. Okay, then frame check sequence to see, to verify whether this is having any errors or not. So receiver will use this frame check sequence to identify where is any errors or not. So end of the frame. This is how this frame format. Okay, the same thing is being indicated in this slide. So whatever we have discussed. But then, so multi-link. Multi-link means, so generally the protocol is itself is indicating about point to point. When it is a point to point, what is the meaning of multi-link? So between a sender and receiver, there may be multiple paths. Suppose for example, so sender is Vijayawada, receiver is Hyderabad. There are multiple links are available. One via Suryapeta, one link via Miryalguda, Guntur Miryalguda. Okay, likewise, for example. Now, some frames may be moving between Vijayawada to Hyderabad via Suryapet. Some frames may be moving via Guntur, Miryalguda to Hyderabad. Likewise, that is, like this support is also possible in this. That is multi-link point-to-point protocol. Okay. If it is a single link, all are moving. Suppose if it is a single link, there is no other path is available. No other path is available between say Vijayawada and Hyderabad. Only via Suryapeta is available. No other is available. In that case, so all the frames will be moving from Vijayawada to Hyderabad in the same path and in the same order. First frame 0, then frame 1, then frame 2, then frame 3 likewise. And it is going to arrive at the Hyderabad in the same sequence. First frame 0, then frame 1, then frame 2, then frame 3 likewise. If it is a single link. When we have multiple links like one via Suryapet to Hyderabad and other is via Guntur, Miryalguda to Hyderabad, then some frames will be moving via a Suryapet link, some frames via Guntur link. Maybe suppose frame 0 is leaving via Guntur link and frame 1 is leaving via Suryapet link. Maybe frame 1 will be arriving at the Hyderabad first. Okay. Then frame 0 may be arrived later. So there is no guarantee that in the destination in this case, whatever sequence they left at the source or sender, they may not be arrived at the destination in the same sequence. But at the destination, after receiving all of them, they will be rearranged in the sequence before processing. This is what is happening. This is what is being supported in multi-link point-to-point protocol. That is about the multi-link point-to-point protocol. So this is what is about the first 2 units of the syllabus.